what is geometric progression? Okay. In case you're asked, though you can't be asked in mathematics to define what geometric progression is, the best way of defining it, you just say it's a kind of a sequence, okay, where you multiply, okay, you multiply the previous, okay, the previous term to get the next term. Okay, so multiply the previous term to get the next term. Okay, so this is all what you can say when it comes to geometric progression. Okay, all right, so under geometric progression, we need to know the formulas that are involved. So we've got 1, 2, 3, 4, 4, 5. I'll just say 5 formulas. Let me just show you this other one right here. So it's 5 formulas plus this one right here. So all these formulas must be known. Okay. Um, there are some letters that you have to know. For example, A. So A means the first term. So A means the first term. So all these things must be known. We've got R. R means the common ratio. So this is the common ratio. So what do we mean when we say common ratio or when we say first term? The first term is the number that is starting, okay, or that is at the starting point of a sequence. So, for example, if you can see this sequence, I've got a 3. In this case, 3 is the first term, okay? And then the common ratio is the number that you are multiplying to find the next term, or the constant that you are multiplying to get the next term. Okay, so let me do example number 1 and see what we are talking about. So example number 1 right here, they are saying consider, okay, consider the geometric progression 3, 3 over 2, 3 over 4. Calculate A, the first term, and the common difference. Sorry, it's supposed to be common ratio. Here it's supposed to be common ratio. Okay, so the common ratio. The next question here, B, calculate the sum to infinity. Okay, so how do we work out these? Without wasting much of our time, the common ratio can be found, okay, or the first term can be found just by looking. We've got A is equal to 3. So the first term is denoted by letter A, which is equal to what? To 3. Now our job is on how to find R. So R, this R is the common ratio, okay? Common ratio is R. So how do we find the common ratio? So to find the common ratio, you get the terms that are following each other, okay? We have got this sequence, let me put it here, 3, 3 over 2, 3 over 4, okay? So we've got these terms. To find the common ratio, we'll get two numbers that are following each other, either 3 and 3 over 2, or 3 over 2 and 3 over 4. So whichever I want to work with. So I'll get a 3. So once you get those two numbers, start with the one which is to your right side. In this case, I'll start with the 3 over 2. And then I say divide by what is to your right. I mean to your left. You get what is to your right, divide by what is to your left side. So there, when we work out things, this will look like this. Sorry, it's a 2 here. Then you say times. What would this look like? It will be something like this. If you don't know how to divide fractions, you must check my videos on how to divide fractions. This, you reciprocate this one here. Okay, it was 3, but it will be 1 over 3, whereby this 3 and the 3 will cancel. Okay, you remain with a 1 over a 2. So this is our common ratio. Our R is 1 over 2. Okay. So the next thing here now is to answer question B. We have found these two things for A. So we say question A right here, we have answered, these are the solutions. For question B, we are asked to find the sum to infinity. So the sum to infinity, you come to the formulas, okay? This formula is for finding the term. So for example, if you are asked to find the term, which is right here, you use this formula. This one is to find the sum, okay? And this also is to find the sum, okay? When given the specific number of terms that they would like you to find the sum of, okay? So for this one, we use this formula when r is less than 1. For this one, when r is greater than 1. Sum to infinity, we use this